Hi, this is Dr. Poonam Upadhyay, Professor in Department of EEE, Electrical and Electronics Engineering in VIGNANA JYOTHI Institute of Engineering and Technology. My today's topic in electrical circuit is transient analysis. So I'm continuing the topic transient analysis, which is one of the unit in electrical circuit across all the courses. So transient is a short duration response of an electrical circuit that occurs immediately after a change, whenever there is a switching operation or whenever there is a power turn on or turn off, a fault appears, whenever load disconnected. So this transient period is very short duration and it gives this spike in voltages and current. Voltages and current oscillates for some time, and this oscillation decays out after some period of time, and then response reaches to these stable conditions. So here is a small example you can see here. There is a voltage which goes to the peak value, and then it oscillates for some time, and then it settles down after some period of time to one steady state value. So this transient exists for very short duration, and it exists because we have inductor and capacitor in our circuits. Inductor and capacitor, they are the energy storage elements. So their energy reverts back whenever there is a change in the circuit, there is a change in the state of the circuit. So resistor don't respond to any transient. So in the transient analysis, there are few time instances which we refer for the analysis. T equal to 0, it indicates the time at which switch is closed. If I take here switch like this, and this indicates that T equal to 0, switch is closed, or I can also say that T equal to 0, switch is opened. So any change in the circuit, it can be mentioned with the switches. So T equal to 0, instant of switching at which switch is closed. T equal to 0 minus indicates what are these circuit before switch is closed. T equal to 0 plus indicates time after switch is closed. Instance of time after switch is closed. And T equal to infinity, it is not the infinite time, it is some finite time under a steady state operation. So as we have seen here in the previous waveforms, like voltage goes up, goes down, and then it settles down to some period. So this period, at some period of time, this voltage is settling down. That we call it time T equal to infinity. Now before we go to the detailed study of transient analysis, we need to understand the behavior of individual element in the circuit. So first, let us take resistor. So resistor, as we have discussed, they don't respond to transient. So we'll take a small circuit along with the switch. Let this is a resistive circuit. At T equal to 0, switch is closed. So we know that VI relationship is V of t equal to I of t into R. So I of t can be obtained as V of t by R. So whenever there is a switching operation, suppose I take the characteristic like this, When I apply the voltage to the circuit, when at t equal to 0, this switch is closed. At t equal to 0, when this switch is closed, this V of t voltage across the resistance will be V. And the same time, if I look at this is the time instant at t equal to 0, switch is closed, I will have the response for current. My I of t will be like this. It will be V by R. Over the time, as the time changes, my current will depend upon the voltage which is applied. I have not applied voltage here as variable. It is a constant voltage applied to the resistance. So resistor doesn't respond to any transient. Current follows the voltage here. Now let's come to the inductor, second element as inductor. So we will take here one inductor with the switches here. This is V, this is L. Now at t equal to 0, switch is closed. So before we go for this analysis, let us take what is the relationship, VI relationship for inductor. VI relationship for inductor. We have V of t equal to L di of t by dt. So there is a derivative relation between current with respect to time. Voltage is L di by dt. So it is change in current with respect to change in time. So what happens? This di by dt cannot, inductor doesn't allow the sudden change in current. Inductor doesn't allow the sudden change in current. So if there is zero current here, before the switching operation, inductor had zero current, right? When there was a zero current, that means this inductor will behave like open circuit, because di by dt cannot change instantaneously. Like voltage cannot develop across the inductor suddenly, right? Because the self-inductance opposes the cause of induced EMF here as per the Lenz's law. So it takes time to develop the inductance across the inductor. So that's why inductor behaves like open circuit. Now let's suppose I have here some current. I0. So if my inductor is having some current before switching operation, right? Before switching operation, if inductor is having some current, so at t equal to 0, when t equal to 0, if switch is closed and inductor is having already some current, right? Again, this is not possible. L di by dt, change in current with respect to zero time is not possible. So this time my inductor will behave like short circuit. Okay? During this period, inductor stores the energy and it doesn't respond to the sudden change in current. So that's how inductor behaves like open circuit here and short circuit here. Now coming to the next element, capacitor. So capacitor here, again we will take the DC source and take a capacitor like this. VI relationship for capacitor is I equal to C dV by dt. I'll take the instantaneous value we are talking about. So we'll take here I equal to C dV by dt. Now again, the development of potential between the plates, the potentials across these two plates takes time to gather here. Okay, so capacitor voltage cannot change instantaneously. Because of this relation, dV by dt, changing in the t equal to 0 is not possible. Because the charges takes time to develop across the capacitor plate. There is a polarization process which takes place and dipole alignment will be there. All the positive charges will gather in the positive plate and all the negative charges will gather across the other plate. So dV by dt cannot change instantaneously across the capacitor. So what happens at t equal to 0, when switch is closed and there is a no potential across the capacitor, we have V0 is 0. So how this capacitor will behave? This capacitor will behave like a short circuit, right? If there is initial voltage across the capacitor, just like previous case, we had current across the inductor. There is an initial current across the inductor. So inductor behave like a short circuit. Now here, if there is a potential across the capacitor already existing before the switching operation, if capacitor is initially charged, so this capacitor will behave like open circuit and all the potential will develop across the capacitor. So inductor and capacitor, they behave differently when there is a switching operation. And in this process, inductor stores energy, magnetic energy, and capacitor stores electrostatic energy. And whenever there is a change in state in the circuit, they behave differently. So that's how initial conditions are very important to know for the transient analysis. In the next lecture, we'll be continuing with the RL circuit. We'll take RL circuit, RC circuit, and RLC circuit, and we'll try to understand the response, the transient response under DC excitation and under AC excitation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.